Hello, everyone. I hope you're having a good day. I'm really hoping that you guys didn't think that I wasn't gonna make a video on the final. I was just messing around with you guys, but we're actually gonna start with the final now. Um, so what we're gonna do is we're going to start with. We're actually gonna first go to problem number 5. Um, And we're going to, okay, so the first thing I want to say is that for problem number 5, this was already done on practice quiz number 3. It's the same problem. So just go check out that video. It's in the first, it's the first problem of practice quiz number 3. So you could just rewatch that. I won't be going over it in this video because we have quite a few problems to go through. We have 6 problems. So in any case, we're going to start with problem number 6. Okay. So for problem number 6, what we're going to do. Okay, so first let's read the problem. Problem number 6. Consider the following unity feedback system. Find the gain crossover frequency, omega GC, the phase crossover frequency, omega PC, gain margin, GM, and phase margin, PM for K is equal to 1. Select K to make phase margin PM is equal to 60 degrees. Choose K to make phase margin PM is equal to 0 degrees, and gain margin GM is equal to 0 decibels. So for for part 3, I wasn't able to get, so you guys can just email Professor Ozturk for the answer. I think I might know what the answer is, but I feel like it's a little bit too easy. So you could always just check in with him. But let's start with part 1. So we're finding omega GC, PC, GM, and PM. One thing I just want to talk about is that for the Bode plot, these Bode plots are not the same in every single graph. These are two specific Bode plots for this feedback system. I was checking some other questions on the documentation and just some problems in general, and it seems to be different. So I'm pretty sure that they are just completely different problems and completely different plots, I mean. So we're going to start with this. So we're first going to find, okay, so let's start with finding the gain margin. And when you find the gain margin, you're also going to be finding the, what is it? Omega PC. I think you're finding omega PC at the same time. Yes, you're finding omega PC at the same time. So they come in pairs. So for the gain margin, what you're going to do is you're going to start at negative 180 degrees. When we go to negative 180 degrees, we're going to draw a line directly to the right until we hit the graph line. So we hit the graph line right over here. And then we're going to draw a straight line down. Oops. Straight line down. So it's about here. I was a little bit off, so it's probably like, yep, that's a little bit better. And this value over here is our omega PC. Okay. So you're going to just look at the x-axis, and you're going to find out, okay, so where is omega PC over here? Just remember that this is this is a logarithm, so it's going 10 to the second, 10 to the third, and then over here is 10 to the 0, 10 to the negative 1. So this is actually going to be a value of 1, and this one's going to be a value of 10. So we're going to count. So this is 1, this is 2, this is 3, this is 4, this is 5. So we know it's in between 4 and 5. It seems to be closer to 5, so we'll say it's somewhere around 4.8, 4.7, something like that, radians per second. Okay, so we do that, and then we draw a line straight up. And we're going to draw a line straight up to the next graph over here. right? And this is going to be our gain margin right over here, GM. So to find this gain margin, we have to draw a line to the left. Let's do that. See if we could draw a straight line, semi-straight. Okay, so something like that, right? And this is a little bit hard to read, especially like when you're going to be doing this on the quiz and you're only going to have one sheet, right? So try to keep it as clean as possible and use a straight edge. So over here, like this is in between 0 and -50. We'll say that the halfway point, which is right over here, I'm guessing, -25. So this would probably be a little less than 30 or something like that. Or is it more than 30? I can't really tell. Halfway between 25 would be 25 and 50. 25 divided by 2 is what? It's 25. So not 11, but it's 22.5. Sorry, 12.5. So if it's 12.5, and that's halfway between, 12.5 plus 25 is that's not halfway between. It's like right over here, right? That's halfway between. So this would be 37.5. 37.5, right? So this is basically like maybe 36, 37. It's going to be a little bit hard on the quiz. And I feel like he's going to give a lot of partial credit for this, right? Or he'll just give you the correct answer just because it's so hard to read. That's why when you're doing it on the quiz, do try to do these lines over here just so that he knows that you know what you're doing, right? Because if you just put like 37, it could just be a random guess. And there's no way of telling. This will actually tell him, okay, so he drew the line, he or she drew the line over here, and then he went up, and then they went to the left. Yeah. Okay. So this is about -36 dB. The next one is going to be when PM. We're going to find PM. Sorry. So for PM, that is when magnitude dB is 0. We're going to draw a line. It's right over here. We'll actually do this in a different color. So it's right over here. And this will tell us our omega GC. It seems to be on this line over here. So it's actually going to right over here. And this is 10 point. Now this is 1. So this is 0 0.9, 0 0.8, 7, 6, 5, 4, 3. So this is 0 0.2. So our omega GC is going to be 0 0.2. Omega GC is equal to 0 0.2 radians per second. And then this one is going to be it's when this hits the line over here. This one is even harder to read. Right over here. Now you would think that, okay, this is close to -90, so it might be like -100, I don't know, 98, something like that. That is wrong. It's actually the distance between -180 to wherever the point is. So we'll say that this is what what did I write down? I wrote down -101. So we're going to say that this is -101. And we're actually going to do a small calculation here. PM is equal to -101 plus 180. Plus 180. And this is equal to 79 degrees. Now, if it was below 180, this would be a negative number, okay? So just remember to keep these values the same. So if it's above 180, then it's a positive number. If it's below 180, it's a negative number. So this is our PM, by the way. PM. Okay, and we've found the first part of the problem. The next part of the problem is select K to make phase margin PM is equal to 60 degrees. Okay. Phase margin is equal to 60 degrees. So when phase margin is equal to 60 degrees, just remember, it's not going to be, like off this graph over here, right, at like negative 60 degrees. It's actually going to be 180 minus 60 degrees, or in this case, it's going to be 60 minus 180, which is equal to negative 120 degrees. Okay, negative 120 degrees is maybe about over here, I would say. Right there. Okay, so that seems pretty simple. And it's going to go down to 10, 10, 0. And it's going to go up to over here. Okay, this is 1, by the way. This value, wow, I was really off. In my original, the work that I was originally doing, I put it at 0.75. So you can see how like you can really mess up doing this problem, just because it's not as easy as doing it on the computer when you can zoom in. So we have it at 1. So this is going to be omega GC is equal to 1. After that, you put it at PM. No, you find where it is relative to here. This one is always a hard one to figure out anyway. So we're going to say that this is, I don't know, if this is 25, this is midway. This could be like maybe 15 or something like that, 18, something decently high. We'll just use 15 for now because that's what I used on my sheet. So we're going to use this equation. K is equal to 10. What you do is you do 10 to the negative, the value that you just found, so 15, and you divide that by 20. If you put this into your calculator, you will get 0.1778, and this is a value K, or the gain. So as I was saying before, for part 3, I'm not too sure what to do here, but in the first problem, the gain margin and PM was 0 and negative 180. Okay, actually. Yeah, I'm really not too sure here. I was going to say it was 0 and 180 for K is equal to 1, but that's 0 and 180, not 0 and 0. Over here, I'm not too sure. 0 degree. Oh, no, I'm sorry. Actually, yeah. Over here, it would be the distance. If it was 0 degrees, it wouldn't be on this line or on this y-axis over here. It would be the distance between or the distance from 180. So it would actually be 180 degrees. And this one over here would be at 0. So what I'm thinking from that is that if this is K is equal to 1 when this is 0 and 180, then I'm also thinking that this would just be a value of K is equal to 1. But I'm not too sure if that's just me making up stuff or if it's actually the answer. If it was the answer, that would be very nice, but I'm not too sure. So I'm just going to say that K is equal to 1 in this case. Okay, so now we're going to go on to the next problems. The next problems are decently, they're not too hard, but they're a lot more work for sure. They're definitely a lot more work. It's pretty much the problems that we were doing before, the PD controllers from the last quiz, but these are now PI controllers and PID. Okay, so we're going to do problem 1. The transfer function uncompensated. The transfer function uncompensated system is KGS is equal to K times 6 divided by S plus 20 times S plus 2, and the desired region is shown below. Design a PI controller to locate the desired root at -4 plus J2. Just to let you guys know, this information is not useful because he gives us the desired region over here, right? So the most important information is this right over here, the desired region. And then sketch the root locus of the compensated system. Okay, so let me open up my notebook. That way I could do problem number 1. 1A. Okay, so to do problem 1A, so in the PD controller that we were doing before, was it PD? I might be getting it wrong, but I think it was PD. What we were doing was we were placing a 0 somewhere in the graph. That way it could stretch, the lines could stretch into the desired region. It could go into the desired area as well. And then that would just be how to solve the problem. This is pretty much the same thing. We're going to be using almost the same equations with just an extra step. What we have to do is we're going to place a 0. Place a 0, right? We're going to be placing a 0. And we're also going to be placing an x at the point 0, 0. So it's going to be placing a 0, and we're going to place an x at the point 0, 0. Okay, so let me show you guys what I mean. So for problem 1A, so actually I could just show you on this graph. Basically what we're going to do is we're going to place an x over here. This is kind of the first step. And we're also going to place a 0 somewhere over here, right? It's going to be 1, 0, but we don't know yet. We have to find out where we're going to place that 0. So, with that, let's label these. This is going to be theta p. This x is going to be theta p1. And this x over here is going to be theta p2. Okay. So what we do is we find theta p first. 180 minus the tangent, the inverse tangent of 10 over 6. Okay, 10 over 6. And that is equal to 121. After that, you find theta p1, which is equal to 180 minus the inverse tangent of 10 divided by 4, which is equal to 111.8. Theta p2 equal to, so in this case, this is an acute angle, right? Because it's going to S desired. So we don't do the 180 minus the inverse tangent. We just do the inverse tangent. I got messed up before on that one. And my answer came out wrong, but I was able to fix it because I realized there was something weird about it. So there was 10. Okay, this is going to be 10 over 14 because this is at 6 and this one's at 20. So we have 10 and 14, and this will give us 35.5. After we do that, we have to use this equation over here. Theta z is equal to theta p. It's going to be slightly different from the last equation. And really the only difference is that it's theta p this time. You just add a theta p in the beginning times the summation of theta p of all the theta p's minus the summation of all the theta z's plus r times 180. So if you can tell right now, there are no theta z's, so we're just going to get rid of that. It's not helpful to us right now. And then we're going to do theta z is equal to 121 plus 11.8 plus 35.5 plus r times 180. And this will give us a value of 268.3. Just remember, we're trying to get it lower than theta z max. Theta z max is always the point farthest to the right. And we're also trying to make it greater than 0. So we're going to do minus 180 over here. R is equal to, can either be plus or minus 1, plus or minus 3, and so on. So we're going to make R -1, and that will make it negative 180. So with that, 268.3 minus 180, this is equal to 88.3. Okay, not too bad, right? Pretty much the same thing, just we added a theta p, which is not that bad. Okay, I feel like, yes, that's why. Let me expand this out a little bit more. Okay. After that, what do we have? We have to find the distance. What is it? The distance from, let's see, x value. The distance from x desired to theta z, also known as x. So here, let me just show you guys. X is equal to y over tangent of theta z. Okay, so the y value is just the distance from here to here, from s desired to the x-axis, and that's going to be 10. And we just found theta z. Just remember, guys, that if you have theta, if theta z is less than 90, then you could just go on to this step. If theta z is greater than 90, then what you have to do is you have to do 180 minus theta z. And that's equal to a number, right? And that's equal to theta z prime. And after that, then you can do this equation, but it would be x is equal to y over tangent of theta z prime. Okay. So if it's above 90, then you have to do an extra step, but this is not above 90. I don't believe any of the questions over here are above 90, so we're good. And this is going to be, just remember also that this is tangent. This is not inverse tangent. Tangent of 88.3. And that is 0.3. Okay, we have that. We're also going to find the distance from the origin. So it's going to be 6 minus, plus 0.3, which is equal to 6.3, right? It's a very small distance. If you want me to redraw that, I will. It's right over here. So we have something that looks like this, right? And this over here is going to be, hold on, this is 6, right? So this is the S desired, and this is at J10. Over here, this very, very tiny distance is X, 0.3. And then this entire distance over here is Z, which is equal to 6.3, right? And if it was, if you had to do this case over here, right, this one that I was talking about before, it would be on the right side of S desired. And then you just like mess around with those numbers, but it's not. This is on the left side of S desired. So after that, you would do. Okay, so you find that value, and now it's time that we could find the gain of this equation. So we're going to find the gain by doing this. A is equal to. Oh, I'm sorry, I haven't drawn everything else. So we have another x over here, the one that we placed, and the original x's. I believe this was at like -2, and this one was at -20, something like that. And we're going to find what is it? The distance of these lines. So this is going to be A, B, C, and D. Okay. So now, to find the distance of these lines, you do the square root of the squares. So the distance from the oh my god, what am I trying to say? The y distance is 10, right? So that's 10 squared. And this is so for A, this point, this is 6 away. So this is plus 10 squared. Sorry, plus 6 squared. Right? And this gives you a value of 11.7. B, it'll look something like this. They're all 10 because it's all on the x-axis. 10 squared plus 4 squared equal to 10.8. C, 10 squared plus 0.3 squared equal to 10. It's a very, very small value. It's like 10.007, I believe. So I just left it as 10. And then D, 10 squared plus 14 squared equal to 17.2. Okay, so we have that. And with that, we can find the gain, also known as K times KD. To find the gain, all of the x's, all of the distances for the x's go on the top. So it's going to be A, B, and D, right? So this line is for an x, this line is for an x, and this line is for an x, right? And then all the zeros go on the bottom. So this is going to be C. And also, we have a coefficient here. This coefficient is 6. Why is it 6? Right over here. This is a coefficient, CO. Okay. And this will give you a value of 36.2. Okay. This is going very, very fast because we learned a lot of this stuff from the last quiz. After that, you have this, and then you have this. Whoops. Okay, cool. And you're going to put the x here and the x here. The graph looks, or the desired region looks something like this. Oops. Okay, that's the desired region. This is S desired on the top and on the bottom. We have a couple more X's and O's. Another X, and over here is the O. Okay, so what's going to happen here? This one is going to point to the left. Point to the left. There's going to be two lines coming out over here. The first line is going to go through the desired region, and it's going to curve down to here. And then this line, going to go through the desired region. It's going to curve down to here. All right, this is what our graph looks like, and our GC of S times GP of S, which I don't think we did on the last quiz. I don't know if he's requiring this, but it's basically just the gain times the coefficient. So it's the gain is 36.2, the coefficient is 6. right? So that's 217. And we're going to put in all the points of that we see on the graph. So it's going to be S plus all the points, right? Yeah. So it's going to be S plus 6.3 over S times S plus 2 times S plus 20, right? So it's pretty much that like you have this equation. It's the same equation over here. It's just that we're going to be, for K, we're going to put in 36.2. We're going to multiply it by 6, right? And then we're going to add that S over here. And then we're going to also add the S plus 6.3 over here. So we're just adding in the 0. That should be a 3. We're just adding in the 0 and the X that we put in and also multiplying it by the gain that we found. Okay, so that's not too bad. After that, we go into problem 2. Now, problem 2 seems pretty simple, and I'm not sure if I'm doing it right. There's quite a few problems that I'm not too sure if it's correct because, it's like we didn't really go over it in depth in class, so I'm not too sure. But from what I can tell here, it's the same exact concept that we're going to be placing an X and we're going to be placing a 0 as well. But we're going to do the pole cancellation method. And we're going to place a 0 over one of the x's that are found in the graph. So for problem 2, the root locus of the uncompensated system, kg s hs is equal to k times s plus 6. And the desired region are shown below. Using the pole 0 cancellation method, design a PI controller that the following design requirements are satisfied. Sketch the root locus. Okay, cool. So with this, we're going to fix this. And just remember, you don't have to do anything with this information. I keep thinking that you do, but you don't, because it gives you the desired region. So what we're going to do over here is we're going to choose a point to place X. And I think we could do it actually for both of them. Oh, okay. So you can't place a 0 over here, right? We can't place a 0 anywhere on the right-hand side. So the only place actually is to place a 0 over here, and we're going to place an X over here. Okay? So with that being said, let's redraw the graph. So we're going to be cancel at S is equal to -1. Okay? So we're going to cancel at S is equal to -1. And then we're going to redraw the graph. It's like, whoops, just like this. DS is going to be a +1, and then there's going to be another X over here. And then we're going to redraw the desired region. So it looks something like this. And then we're going to make this. And it's just going to look something like this. Right? Very, very simple. So that's problem number 2. We're now going to go on to problem number 3. It's very simple, as I said. Problem number 3. Let me find where I did it. Problem 4. No, this one's problem number 3. Okay. We're actually going through this pretty quickly. I don't know how long I've been recording for. I don't know if I can check actually. I do not know. Oh well. Problem number 3. This. Oops. Okay. Do that. Brush. There we go. Okay, so for problem number 3, we're going to be doing PID. Now, PID Is this the one that switches it up? No, this is... Is it? Wait, hold on. No, it's not. It's the next one that switches it up. Okay. Yeah, let me just mark something down because something happens in the next problem. Oh, no, never mind. Something happens in the next problem, so I need to make sure that I go over that because it will mess people up on the quiz, on the exam. So for this problem, what we're going to be doing, okay, so we have two x's over here. Now in this problem, this one's an interesting one. For PD, we were just placing a 0, right? We were just canceling something with a 0. Or sorry, not canceling something with a 0. We were just placing a 0 somewhere in the graph to kind of get it into the desired region. For PI, we were placing a 0 and also placing an x at the point 0, 0. For this problem, though, we are going to be placing a 0, canceling an x with a 0, and also placing an x at 0, 0. So a lot of stuff happening. First, let's do this. So there is an x at 0, 0 now. And we're going to be canceling one of these points. We're going to cancel this point at the bottom. And we're also going to try to find where this next 0 is supposed to go, right? Because we don't know where it is. So the equation will look something like this. We have theta z2. Sorry, actually, we're not going to do that right now. We're going to do the equation in a few seconds. But this is theta p. This one is theta p1. Let me draw the lines too. This is the s desired, right? And this is theta p2. Theta p2, which is also equal to theta z1. And that might get a little bit confusing a little bit later, but I'll talk about that. Anyway, let's find these values. Theta p is equal to 180 minus the inverse tangent, sorry, of 10 over 5, right? Because it's distance of 10 for y and then a distance of 5 for x. And this is equal to 116.6. We're going to find theta p1. Theta p1 is equal to 180 minus the tangent of 5 over 5, which is 135, because it's basically just 1, inverse tangent of 1. And then the last one, theta z1, which is equal to theta p2, is equal to 180 minus the tangent, minus the inverse tangent, of 15 over 5. 15 over 5. Is that, yeah, 15 over 5. And this is 108.4. Okay, and then finally, we're going to write this equation over here. Theta z2 is equal to negative theta z1. So this is a theta z1. Actually, let me just write the whole equation so I can tell you why it might be a little bit confusing. Theta p plus the sum of all theta p's minus the sum of all theta z's plus r times 180. Right, so you can see right over here that this is the sum of all theta z's. And that might get a little bit confusing because over here is theta z1. You could kind of include that in this theta z because it's going to be negative either way. Or you could just label this as a over here, right? and this one's A. Or you could just leave it alone, right? You could just leave it as theta z1, and that's completely fine too. But I don't want you guys to get confused with that because there's actually going to be no other zeros here besides the theta z1 that we placed in ourselves, right? These theta pi's and theta z's are usually just whatever is given to us in the problem. So if there's an x given to us, or if there's a 0 given to us, then that is included in the summation. But this theta p is on the outside and this theta z1 is on the outside because those are the ones that we placed ourselves. So moving on, we're going to do theta z2. Theta z2. Yes, we're going to calculate theta z2. So one thing about this is going to be 108.4, and it's actually going to cancel out with theta p2, obviously, because they're at the same point. This is plus 116.6, plus 135, and this is the plus 108.4. This is a positive 108.4. And this is plus r times 180. Okay. So as I said, these 2 points are going to cancel out, and you're left with theta z2 is equal to 251.6, and you're going to choose an r value that makes it less than theta z max, which is supposed to be, I believe it's 116. It's 135. Yes, it's 135. So it has to be less than theta z max and greater than 0. It seems that we're always placing r is equal to -1. It might not be that way on the quiz. On the exam. God, it's so weird to think that we're having our final exam. So for me, actually, I think for everybody, this is actually my final exam. This is Professor Ozturk's exam. Is the final exam I will ever take at Manhattan College. So that is pretty interesting. Let's see. So going back to this is theta z2, 251.6. So this is going to be -180. It's usually -1, but as I said, it could be -3, +1. It just depends on the case, and this will give us 71.6. In this case, theta z is less than 90, so we don't have to do the whole theta z prime stuff. We could just go straight into this, which is 10 over tangent of 71.6, which is equal to 3.3. And then we can find the value of z, which is 5 plus 3.3, which is equal to 8. This should be 3.3. Doesn't really matter too much, but 8.33. And to draw that on a graph, it would be, this is the s desired, right? And this is 3.33x. And this whole distance is z is equal to 8.33, right? Okay, so now we are going to find the gain. I still can't believe that on the last quiz, I was like teaching people how to do some stuff, how to do some stuff for the quiz. And I was just like, don't forget to put the gain, right? It's like not too useful. It's kind of just like a little side note, but it's very important because you could get a lot of points off for it. And then I forgot to put the gain myself. It was like, what the hell? But anyway, we're going to be finding these distances. right? And there's a 0 and an x over here, so we're going to be finding this distance twice. So this is going to be A, B, C, C, right? We'll just put it down twice, just as a reminder. And then this one is D. Okay. A is equal to, I did it in reverse on my sheet, so I got to remember not to reverse the numbers. 5 squared plus 5 squared equal to 7.07. B, okay, go down there, Charlie. B is equal to 10 squared plus 5 squared is equal to 11.18. C is equal to 10 squared plus 3.33 squared, which is equal to 10.54. Sorry, yeah, I reversed it by accident. So it should be, this is 5, this is, oh, I have to go even back more. 15 squared plus 5 squared equal to 15.81. D is equal to 10 squared plus 3.33 squared, which is equal to 10.54. That looks like a 7. 10.54, right? And then our gain equation, or K times KD, is equal to, it's going to be all the x's on the numerator and all the zeros in the denominator. So A is going to be A, B, C. And then this one's going to be C and D. And there's also a CO, which is equal to 0.1. Hold on. 0.1 as stated over here. 0.1K. Right? So we have that. And this is just going to give us a value of 75. To move on to part 2, we have to draw this. So this is going to be here now, and this is going to be here. The desired region is going to look something like this. And then the S desired is going to be over here, I believe, and over here. And then the 0 is going to be somewhere over here, right? At 8.33. So what's going to happen is this is going to come over here. It's not going to go into the 0. Just remember that it'll only go into the 0 if there are 2 zeros over here, and it would go like right in between. This is going to go somewhere over here, past the 0. This one is going to go somewhere over here, past the 0. Okay, and then our GC of S. I did GC of S times GP of S before. Now I'm only doing GC of S. In one of the problems, he only wrote GC of S over here, and then another problem, he did GC of S times GP of S. So I'm just doing it like he did in the example problems. But this is basically just writing all of the points. If you just want to write GC of S, it's only the points that we added ourselves. So that would be the S plus J5. This is a 0 that we added over here, right? There was an S plus 1.67. 1.67? What is the 1.67? I don't remember what that is. I think I wrote that wrong. 1.67. That sounds like something from one of the practice problems I did. That should be... Okay, well, there is definitely an X that we added right over here, right? That's included in the drawing. This is a 0 at 8.33. So this should be, this should be 8.33. I know what I wrote before. I wrote 1.67, and I believe I was looking at, I just kind of accidentally copied it down from the example I was looking at. This is 8.33. And that's our GC of S. And of course, you could multiply GC of S times, oh, I forgot to write the gain, which is 75. You can multiply GC of S times GP of S. And then you would get, you would be able to cancel this one out, and you would look something like GC of S times GP of S. This is S on the bottom, S minus J5, I think. Am I canceling out S plus J5? Yeah. S minus J5. And then the 0, S plus 8.33, 75 times 0.1, so 7.5K. 7.5K. Okay. Yeah, I think on the last one I forgot I did not put K. I just left it alone. But it seems like you have to include the K. This one is 217K. Okay. So that's good. So we have that now, 7.5K. Yeah, I said before that you have to input it into K, but I think that's just wrong. 7.2. Okay. And now we're on the last problem. That was very quick. I was able to do that fairly quickly because I'm on computer now instead of a laptop, which is nice. Problem 4. Oh. Stay in the call. Okay, problem 4. Problem 4. Okay, so this one is pole zero cancellation method, and we know that pole zero cancellation method is very easy to do because you just cancel it out. Sadly, this one is not easy. It's not as easy to do as the other pole zero cancellation methods that we were doing before. And it does still require, like, even though it's not easier, it does still require trial and error. So you might be able to get a whole problem wrong, or sorry, not wrong, but you might be able to figure out that you can't cancel it at a certain pole, and then you would have to redo the whole problem again. I am not going to. Should I? Maybe, I mean, I guess I can, but like, I don't really want to. I'm going to do the problem correctly, and I'm going to tell you which way, where it was supposed to be canceled, and then I'm going to explain to you why the other way doesn't work, but I'm not going to go too in depth with this, right? So let's do the problem correctly. The correct way to do this problem, and you probably won't know this on the quiz. I don't think there is a way besides trial and error. You're going to cancel this pole over here. Okay. And you're also, for this one, you have to cancel a pole and then you have to place another pole. I think. Cancel a pole and then place a 0. Cancel a pole. No, actually. Okay, so this is what's up, guys. You're canceling a pole with a 0, and then you're placing another pole. Right? You're actually not placing a 0 this time. You're actually placing another X. So, so this is going to change up how to do this problem a little bit, and this might even confuse you guys. So I'm going to let you know where you're supposed to worry about things. So let's do the problem normally for now. So you have a theta z, right? And this is equal to the same as this value over here. So this is theta z. This is equal to theta p1. Yep, so theta z is equal to theta p1, which is equal to 180 180 minus tangent, inverse tangent of 8 over 5, right? This is equal to 122. Okay, and then you have another point over here, which is theta p2, right? No difference so far. Theta p2 is equal to 180 minus inverse tangent of shoot, I can't even read that. I think that says 5 over 3. 5 over 3. That doesn't make any sense. It would be, this is 8. 8 over 3. Yeah, 8 over 3. Okay. 8 over 3, which is equal to 110.6. Okay, so we have those two values. Okay. So as I said before, we're trying to place an x. So most of the time we were doing like this equation, theta z is equal to, I don't know, it would be like the summations, right? Or you would have a theta p, theta p over here, right? And then you might even have a theta z over here, theta z1, right? That is not the case for this one. This one is actually going to be, we're trying to find theta p. And this changes things up in the equation. Theta p is equal to theta z, the one that we just placed, plus the summation of theta zi minus the summation of theta pi. So you can see right over here, that these two are switched up. Now the theta, oh, I forgot to do one other thing. Actually, you know what? I can do one thing. Here. This is, the theta z's are now positive, and the theta p's are now negative. Okay, so you're going to have to remember that for the quiz. Don't get that confused. For pole zero cancellation method, design a lead controller, you're switching the summations. Normally it would be negative over here and positive over here, but now it's the reverse. So, and then the final thing, which is plus r times 180. There we go. Plus r times 180. Okay. Theta p is equal to negative 1. Why did I write negative? Is it negative? No, it's not negative. Oh, right. Okay, right. Because wait, hold on a second. Theta z. Hold on. Trying to remember what I did here. So if theta z is negative. Oh, I think I just forgot to put a negative. No. This is positive. Because theta pi, yeah. Okay, so this is positive. Okay, so 110.6. Sorry, I'm doing it wrong from the start. I see why now. Okay, 122 plus 0 minus 110.6 minus 122, right? Because there are no other theta zi's besides theta z. So this is theta z, and then these two, the two theta pi's. Okay. And then you have plus r times 180. 80. After that, you find theta p to be negative 110.6 plus 180. Right, we're going to choose positive 1. This is the only time we choose positive 1 for this exam so far. Well, I don't know how it'll be on the actual exam. It could be positive 3, negative 3, whatever. And then we're going to do 69.4. 69.4. And we now know that theta p is less than 90, so we don't have to do the whole thing afterwards. So x, to find x, we do x is equal to y over tangent theta p, which is equal to 8 over tangent of 69.4 equal to 3. P is equal to 4 plus 3 is equal to 7. Okay, so now we know where everything is. So we draw the graph. This is x. This is another x. We cancel this x, and we now know that we're going to place an x over here, and this is our s desired. We're going to find the gain now. This is a, b, c. A is equal to square root of 8 squared plus 5 squared, 9.4. B, okay, I'm not gonna write all of these. It's 8.5, and C is equal to 8.5 as well. You guys should be able to figure out why that is. K and KD. So it's going to be all of the x's, so A, B, and C, over all of CO, which is 10. Over all of the O's, which is at point A. This will give us a value of 7.2. Okay, and then to end this off over here, before we go to like why the other one is wrong. So this is our desired region. X, X. Okay. Remember that it's in between. There's a hold on actually. This is the S desired. This is the S desired. It's the distance in between these two x's. So this x is at -1. The other one is at 7, right? 7? Is that 7? Yes. 7? Hold on a second. I gotta remember if I did this right. Okay. Four plus 3 is equal to 7. We do. I might have done this wrong, which I'm not happy about. 9. That would be 5. This one would be 6, right? Because it's at -1. This is at -1, and this is at -7. Then the distance would be at, in between here, be 7 minus 1. which would be 6 divided by 2 is 3. So it would be over here. And then this would point up. But it wouldn't go through the desired region or the desired area. That's tough. That is tough. I can try to attempt to see if this is like if I messed up somewhere, but the desired. Hold on. Yeah, let's go back to this. Desired S desired is -4, right? So this is at -4. Pull 0, yeah. And this one is at -1. This one's at 7. Not too sure about this one, actually. Yeah, I don't know if I'm going to be able to figure this one out, guys, because I did the other method too, which I was going to show you why that one was wrong, but one of these has to be right. If D is equal to -4, this is located 3 away, which is at 7. Yeah, if it was at like 9, then that would be fine. Right? Because if it was at 9, then it would be -1. And you divide by 2. And that'll give it right in that, yeah, because like we want it to go through the desired region, but it's 1 off. And that's actually the same problem I had with the other way I did it. And I don't think I'm going to be able to figure this out. If you guys like look at this by yourselves and go over it, see if you can figure out how to get it to -4. You could leave a comment in the video. But I guess I could go over the other method. So in the other way, either way, like even if you guys can't figure out how to do it, and I don't figure out how to do it, the other way is just doing this work, just doing all of this work and getting partial credit, which is always fine. It's better than not doing this problem, right? So the other way was if I had canceled it over here. If I canceled it over here, right, this is the x, this is the x, canceled it over here, and we were going to place an x somewhere over here, right? Then instead, what is it? Theta P1. Theta P1 would be the same, 122, and theta P2 would be the same, with theta Z1 would be equal to theta P2, or theta Z, I mean. Oops. Theta Z is equal to theta P2. After that, you have theta P is equal to 110.6 plus 0 minus 110.6 minus 122 plus r times 180. And that's equal to 58. X is equal to y over tangent of theta p, and this is equal to 8 over tangent of 58. And this will give us a value of 5 this time. When you get the value of 5, though, what happens is p is equal to 4 plus 5, right? Because it's a distance of 4 plus 5 away, which is equal to 9. I'm not going to do the gain because that's not too helpful. When you get it to be a distance of 9, what happens is, so you have this one that's canceled, right? And you can't even place a 0 over here. Or sorry, you can't place a 0 on the other one. So man, you can't even place a 0 on the right side. So I don't know how that one would be any more correct. But anyway, so you're placing a 0 over here, right? Because that's the only place you actually can put it. And this is at -9. This is at +1. And the S desired is over here. SD. Right, SD is over here. And this is at -4. But the problem is, so this is nothing. The problem is this is at +1, this is at -9. So this is just 9 plus 1, which is equal to 10. And if you were to take the distance between these two, it would obviously be 5, right? Because 10 divided by 2 is equal to 5. So, I mean, if you were to do 1 minus 5, that would be -4, right? But if you were to do 9 minus 5, oh wait, what am I doing? 9 minus 5 is -4. Oh, okay. Sorry, or whatever. Okay, so this is correct. Oh wow. Okay, so I just showed you guys how to do it the wrong way, and now this is the correct way. So if you do 9 minus 5 or 1 minus 5, that will give you a value of -4. Well, actually, 9 minus 5 would be +4, but that's the distance away, right? So it comes down to -4, and then there's an x over here. So as I said, it's in between this x and it's in between this x, which is at -4, and it'll just go straight up through S desired over here and over here, straight down as well. So it's in the desired region. It's going through S desired, and you were able to do the pole zero cancellation method. So luckily, this should be a simple problem, especially if he puts one of the x's on the right-hand side of the graph, because you can't put a 0 there. You can't put a 0 on the right-hand side of the graph. So there's only really one option. If there's two x's, and one of them's on the right-hand side of the graph, then there's only one option. Okay. Yeah, and really the only thing left to do is to figure out what is going on over here for choose k to make phase margin PM is equal to 0 and gain margin GM is equal to 0 decibels. But this is pretty good. We were able to go through most of the Problems, there's really only one left that we weren't able to do. Um, and well, you guys got your video, of course. I wasn't actually planning on leaving you guys hanging for the final exam. Last time we're ever going to be taking a test together. Um, but I just thought it would be fun, uh, just to see how you guys would react. Um, but this is how you do the final exam. I hope you guys do well on this exam. I hope you guys get 100, honestly, and that you just enjoy the last bit of college. Our graduation is coming soon. If you guys are going to be going to grad school, good luck, right? Especially if it's another like 1 or 2 years or however many years at Manhattan College. Good luck. I hope you have fun and enjoy taking classes with Professor Iakos and all the other professors, Professor Ostrich maybe. Um, if you guys are going to be getting a job, good luck with that. Enjoy just making money and being able to continue on with your life and just develop new skills. Um, and that's pretty much it. Hope you guys have a good end of the semester, a great graduation, an excellent post graduation, and I will talk to you guys another time. Have a good one, and oh, whoops, I'm not on the thing. Have a good one, and have a good night. Bye bye.